Right, good day everyone. Thank you all for participating in the IaCConf Spotlight today. Big thanks to Spacelift, especially Gareth, Gabriella, and the team behind the scenes for hosting this event, as well as Ruby and Pravesh for their fantastic talks. My name is Rishav Dhar, and I'm based in Edinburgh, Scotland, where I'm employed as a senior DevOps engineer by the Wavelo division of Tucows, where we modernize telecom systems for operators worldwide. While DevOps is a bit of a buzzword, my actual day-to-day involves provisioning infrastructure as code, processing app deployments, streamlining code delivery to customers, and if I'm lucky, getting engineers to self-service pipelines themselves. That there is a picture of me at a local tech meetup trying to brave my way through public speaking. And speaking of myself, before DevOps, I have a background in observability, leading site reliability monitoring at a fintech, software QA test automation at a legal tech before that. On the side, I've been increasingly getting into open source, started by contributing a few lines to niche projects like custom keyboards, and nowadays maintaining a small fleet of projects, one of which we'll look at today. Outside of work, you can usually find me outside tramping over the wee hills around Scotland. The first picture is of a Shetland cattle, a brief walk from my home. And that's enough about me. Back on topic. For this talk's outline, we'll explore framework pieces which build towards our final IaC pipeline, starting with short-lived authentication, which you might know as OpenID Connect, then environment protection to prevent unauthorized deployments, followed by GitOps workflow curated for Terraform Tofu PR automation, which all leads into GitHub Action integrations to demonstrate some examples of best practices. Before diving in, it's worth taking a moment to consider why should we be motivated to secure this pipeline. After all, most IaC projects tend to be private internal, so what's the point? If you're attending IaCConf, it's likely you're in the near 60% of folks using IaC tool like Terraform or OpenTofu, at least in AWS. This is great news for improving version control and traceability, and it's also the first step towards zero-touch production environments, which heavily rely on robust automation as opposed to manual error-prone click-offs. However, there is still too much reliance on hard-coded, long-lived credentials within pipelines. To put a number to it, almost 60% still leverage IAM users fully or partially. Now, while that's down 5% from last year, over the next 30 minutes, I want to convince you to drive that number down further. By the way, both of these charts are courtesy of Datadog's 2025 report on the state of DevSecOps. Now that we have a goal, let's get started with the first topic, short-lived authentication. This one's a bit heavy on jargon, so I prefer to stick with the analogy of concert tickets. Bear with me. Let's say we are issued our ticket online by a vendor. We present it at the entrance of the concert venue. We're granted entry to our designated seat for the duration of the concert, after which our ticket is no longer of value and can be safely discarded. In much the same way, GitHub Workflow issues a request with a specific role ID. That's our ticket. The request is then checked by our cloud platform, such as AWS, GCP, or Azure. That's the concert venue. If validated, the platform grants access to resources permitted by the role. That's our designated seat. And these credentials are short-lived and typically expire within an hour, rendering them safely disposed. This implementation of short-lived authentication is better known as OpenID Connect, or OIDC. Since the OIDC provider is set up ahead of time, there is never any transfer of hard-coded secrets. And most modern cloud platforms support signing their pipelines with ease, along with comprehensive guidance available online. For example, in this screenshot, we see GitHub docs. This improves our security posture massively, and as the old saying goes, you can't leak what you don't have. And while I don't intend on us spending more than a minute on this code snippet, I have included it just to demonstrate some of the broad range of options that can be configured when setting up OIDC. For example, only allowing a certain branch or branch pattern to assume a role, or only allow certain environments to assume a specific role. This can be particularly powerful in securing an IaC pipeline with plan and apply specific roles, where the plan role is read-only, making it perfect for updating or opening pull requests, while the apply role is read and write, requiring some sort of secondary review before merge and deployment. And speaking of deploying to environments, in comparison to OIDC, preventing unauthorized environment changes is a little more straightforward. Many of us might be familiar with the concept of a code ownership file and how that automatically tags reviewers when certain directories are modified by a pull request. GitHub protection rules takes this further by requiring a secondary review at the point of merging a pull request. Often, these reviewers are non-technical stakeholders, since they get to decide when pre-approved changes are deployed with their audit-friendly sign-off. We see an example of this deployment review in the first picture, with a who did it, in this case it was me, where was it deployed, in this case prod, and for what reason, none given. As for the second picture, that shows how multiple environments can have varying levels of protection. For example, we would probably prefer a secondary review or two before changing production, but we should allow for less stringent checks to keep dev environments iterating quickly. And much like with OIDC, these deployment protection rules are pretty configurable, with the ability to require approval from multiple people, think tagging your security or network teams. And they can also apply to a particular branch or branch pattern, depending on your branching strategy. In the third screenshot on the right side, we also see a configurable wait timer to force a buffer period before processing your deployments. But that's enough info dumping. We've covered a lot of ground in the last few slides, so let's check in with a selection of 3 questions. Now don't worry, not putting anyone on the spot. All I'd like to do is determine how many of these questions you're able to answer confidently. Feel free to be honest, since it's purely to help me get a better idea of pacing this session, and whether anyone is actually there on the other side. So simply pick between 1, 2, or 3 for however many questions you're confident about and post it in chat. That's it. I'll read out the questions for ease. The first question we have is, why are short-lived credentials preferred? Next up, how does deployment protection differ from code owner's file? And in third, when do we get to the IaC pipeline? We'll leave a few seconds for the poll while I get a sip of water. Alrighty. Ooh, that was exciting. I saw a poll for a second, and let's see. Oh, it's already been filled out for me. Brilliant. Out of curiosity, where do I get to see the results of the poll?
I was trying to figure out the same thing. This is a new feature we're testing with the platform here for IaCConf. I'll tell you the results. So we've got 7 votes for they can answer 1 of the 3.
Gotcha.
We've got 22 votes they can answer 2 of the 3, and 12 votes can answer all 3. So
brilliant.
2 of the 3 is your heavy.
Absolutely. Looks like 2 is the most popular pick. Brilliant. Yeah. We'll go ahead and rattle through the questions from the top so that we're all on the same page. With short-lived credentials, they're preferred since these temporary credentials typically expire within minutes, rendering them useless to attackers. And unlike hard-coded secrets, Short-lived credentials don't have to be rotated, as new ones are generated each and every time. Moving on to the next question, the code owner's file is a fairly basic standard requirement for code reviews, whereas deployment protection rules serve as a secondary review at the point of merging a pull request. And oftentimes, non-technical folk are assigned for their auditable sign-off. As for the IaC pipeline, I hear ya, let's move on. In the back half of this presentation, we get to dive into the nitty-gritty of our IaC provisioning pipeline. Specifically, GitHub Actions makes it easy to automate workflows, whether it's to build, test, or deploy. But what makes it stand out for our Terraform Tofu use case is that the workflows are carried out on ephemeral runners. In other words, a new temporary instance is spun up within seconds, it runs Terraform Tofu plan or apply, and then it gets wiped clean to do it all over again, which is pretty brutal, all things considered. But what's more is its zero overhead nature. There is no need to self-host or maintain additional infrastructure, unless of course you're opting for self-hosted runners. And with access to the GitHub Marketplace, there are plenty of first-party integrations. Just one such example being the AWS configure credentials, which I'm sure a lot of folks are familiar with, for responsible for authenticating pipelines with OIDC. And while we're on the topic of automation, many of you will be familiar with Atlantis and wonder how that compares with our GitHub Actions approach. Atlantis is a solid open source offering which paved the way for Terraform automation via pull requests. And it remains one of the most customizable choice, thanks to its breadth of configuration options. Where I believe it falls short is its lack of OIDC support and GitHub native features. Thereby, it relies on static credentials, which have to be rotated separately. And since Atlantis operates via webhook, it can't take advantage of GitHub's inbuilt environment deployment protection rules. Not only that, since it's a persistent compute instance, you're also responsible for bringing up and maintaining infrastructure which hosts Atlantis for you. This can be particularly prickly when it comes to audit trails, storage of secrets at rest, and provisioning least privilege access across live projects between your company. As a brief aside, I wanted to touch on the two phases of Terraform and Tofu. There is, of course, the plan phase, where changes are proposed and reviewed, and the apply phase, where approved changes are implemented. I think it's worth taking a moment to consider how planned changes should be displayed to convey impact meaningfully. I mean, oftentimes we're spat out these thousands of lines long plan, and it isn't very easy to figure out what is it actually doing. So this could take the form of diff syntax highlighting, you know how you often see in Git with your additions in green, modifications in amber, and deletions in red. Though it can be necessary to summarize these diffs for particularly large changes. Not to mention, how do we ensure only approved changes get applied? If we simply apply with auto-approve, we cannot guarantee that planned changes are deployed. We're just applying whatever is the infrastructure state at that particular time. And speaking of, nor does it account for configuration drift outside of the pipeline, which Parvesh touched on in the earlier talk. And if we're somehow able to store and retrieve plan files between plan and apply, how do we ensure it's encrypted to prevent exposure of secrets in between? All of which culminates in the Terraform Tofu VIA project by OpsDev, using best practices for secure and scalable IaC pipelines. And it implements each piece of the framework we've built together today within a GitHub action. I'll go ahead and paste a link in the chat, but there will be plenty of links and resources at the end of the slides if you want to follow along. As for the project itself, this open source project is freely available under the permissive Apache license and has been actively maintained by myself and contributors for going on 3 years now, actually. along with plans to take it further. For example, implementing Terra Grunt support. But we're getting ahead ourselves. Let's take a peek at some of the input-outputs from TF via PR. Here's a breakdown of a typical GitHub workflow, where in the first picture we have some usual boilerplate setup, such as checking out your PR branch, followed by OIDC authentication with AWS. That's where we are practicing our short-lived credential authentication. After that, we're installing Terraform or Tofu CLI without wrapper. In the second picture is where we get to configure TF via PR to fit our particular setup and needs. So first up, we pass in a working directory. That's simple enough. Then we have a conditional input, which is either plan when the PR is opened or updated, or apply when the PR gets merged in, all decided in a one-liner. This cuts down on repetition significantly by consolidating your separate plan and apply pipelines within the same workflow. And it's also compatible with other event triggers, such as cron schedule, for example, if you're wanting to automatically run a plan every hour or so and open an issue or create a ticket if there is any configuration drift. Below that, there's a bit of a gap, and we can then pass in any number of options with the arg prefix for the whole gamut of CLI arguments available in Terraform Tofu. In this particular example of the screenshot, we input lock, backend config, var file, and workspace. Now, some of you pros might have clocked that these arguments are actually supposed to be passed into separate commands of the Terraform Tofu CLI, such as initialize has to go first with the backend, then you do your workspace selection, and then you move on to plan or apply with lock and the var file. Thankfully, the GitHub action takes care of slotting the arguments into the right commands for us. And now we actually get to see what a typical output comment of TF via PR looks like. Up top is a one-liner of the last command run, without any sensitive inputs like your API token variables that often gets passed in within CI pipelines. In this case of the screenshot, we see it's running Terraform apply within the platform's dev directory. Simple enough. Next up, we have a color-coded diff of changes to help summarize the scope and impact at a glance, helping us review changes and protect against unexpected deployments. It's got the color coding we mentioned earlier, and it also references each resource that gets touched, modified, added, or removed in a one-liner so you can scan through it a little easier. And of course, immediately below that is another collapsible section with the raw plan in HCL format. We never want to lose the source of the data, and we want to keep it all together in situ in the same place. And for anyone thinking ahead, if you have some large changes coming in which exceed the character limit of a GitHub PR comment, there is always going to be a direct link to access the raw workflow log in its entirety. And on the topic of access, some eagle-eyed viewers may have noticed the little edited text dropdown at the very top of the comment. Clicking it reveals a timeline of the inline edit history of changes made on the PR branch. This spans all the way from the first plan when the PR is opened to the last apply when it finally gets merged. And each change is accompanied by a triggering actor and a UTC timestamp to help keep track of changes in a collaborative GitOps framework. This has been fantastic, especially for a number of our workflow use cases where they often take commit after commit, and especially if you're working on a new module and you're trying to make sure it's servicing the way it should be, this is super helpful to keep tabs on what's changed over time and how that's affected the plan. And all of that brings us to the broader GitHub ecosystem of tooling integrations. To get it out of the way first, as you can see from the screenshot, there is first-class support for running jobs in matrix strategy with TF via PR. As for the plan file, that gets encrypted and stored as a workflow artifact with a deterministic name whenever a plan occurs. For reference, this same deterministic naming convention is used to retrieve and apply the appropriate plan file. And if you happen to be operating where there is a high frequency of changes being merged in your team or project, you'll probably relate to finding yourself waiting for pre-PR branches to replan after each and every merge. And as such, this GitHub action features a plan parity toggle, which compares the old plan file with the newly generated one in the pipeline. And if they're identical, it will automatically apply the new one instead of complaining about needing to refresh the stale plan. And after Ruby's presentation, we understand that Terraform and Tofu doesn't exist in a vacuum. With various open source integrations like Checkov and TFlint to provide contextually aware action items, all together seamlessly within the same pipeline. And on to our second and final audience check-in for the day. You know the drill with the 3 questions. Simply pick between 1, 2, or 3 for however many questions you're confident answering. And I'll read them out for now. First question we have is the pros and cons of GitHub pipelines. Next up, we have why reuse a plan file during apply operation. And then last, we have what's the name of the GitHub action. We'll leave a few seconds for the poll while I get another sip of water.
Still haven't figured out how to share the share the responses, so I'll read them out here.
Oh, brilliant! All good.
Yeah.
Like the Coldcast guys, they've been super helpful so far for the most part. So there must be a way. I just don't know what it is.
Yeah, there definitely is on the platform. So distribution's pretty similar. So we got 7 folks who can answer 1 of 3, 16 who can answer 2 of 3, and 10 who can answer all 3.
Gotcha. We're definitely towards the 2-3 side of things, with a few folks still on the 1 as well. No worries there. In that case, I'll go ahead, rattle through the questions from the top as before. With the GitHub CI pipeline question, they are ephemeral by nature, making them perfect because of their zero overhead for maintenance and making them ideally suited for modifying infrastructure. And it's worth noting, we haven't really touched on the drawbacks today. So perhaps the most sticky one is we're adding a dependency, namely GitHub. Then again, we also trust GitHub to host our code base, so perhaps it isn't the biggest worry, but it is worth planning for outages. And that goes for any pipeline, even with Atlantis. Moving on to the next question. The plan file captures a snapshot of the change proposal at a moment in time. Reusing it during apply protects against configuration drift since the creation of the plan. Without it, we would be approving changes blindly without any guarantee that the state of the infrastructure hasn't changed underneath us. And as for the GitHub action, I hope we remember it's called Terraform Tofu via PR, or TF via PR for short. In closing, we stated our goals with the IaC pipeline up front. From the short-lived authentication with OIDC to avoid hard-coded secrets, to leveraging GitHub native features like environment protection rules to manage deployments with automated compliance trail. All together culminating in the GitHub action, which flows through each piece of the GitOps framework, running on ephemeral, extensible GitHub runners without needing to self-host or manage underlying infrastructure. And at this point, I'll just interject kind of quick. I noticed in the chat, Kenneth mentioned using AWS CDK for their AWS environments, and that's perfectly viable and useful as well. You don't have to necessarily rely on GitHub. Any ephemeral runners will do this for you. With that, feel free to ask me anything, and I'll try my best to answer. And if you remember something afterwards, you can easily find me online at rdar.dev.
Great job, Rishav. We do have some questions that were submitted in the Q&A. If anyone else has any they want to drop in, you can do so now and upvote any that are in here. So I'll just pull these on screen and let you answer them as they come up. So
Sure thing.
First question here from Matt. How would you manage drift detection using a GitHub Actions pipeline?
Oh, this is brilliant. This is perfect. The TFI PR already has a demo workflow for this. What I usually tend to do is, since you know the working directory and what configuration you need to run a plan, what we do is we have a GitHub Action workflow that is cron scheduled to run every hour of every day. All that is responsible for is running Terraform plan. And if there is any difference between the provisioned infrastructure and what's written in code, it will trigger a notification. In our case, it opens a GitHub issue, notifies Slack. You could just as easily have it integrate to create a Jira ticket, for example. And by utilizing the GitHub native features, we're not introducing new software toolings into the mix. We're sticking with the one source of truth we have and managing it all in code.
All right, great. Thank you. All right, next question here with 3 votes. Do you do the Terraform apply before PR merge or after merge?
Oh, that's such a brilliant question and definitely not taken from the slide. So I've had a couple of questions on slide which always get some conversations going. This is a brilliant one because when it comes to comparing before and after, I think the most folks you talk with will very quickly align with wanting to apply after merge. And there is really good reasons for it. It's a little bit more GitOpsy, so that your main branch always reflects the source of truth, and there is less ambiguity about which PR branch is applied and how do we lock out the other PRs. So I think the easy answer in that case would be to apply after merge. With that being said, I did happen to write a little article blog post not so long ago, and it happened to be picked up by Anton's weekly newsletter. And here I try and make the argument for why not both, using another GitHub feature called merge queues. This is a little bit of a can of worms, but I do recommend giving it a glance, giving it a gloss read through, where I try to make the argument for merge queues, which tries to bring together the best of both merging before the PR or applying for the PR and applying after the PR is merged.
Great. Check that article out. Thanks, Rishav. All right, question here from Kareem. How do you manage, config all of those OIDC trust policies at scale?
Spectacular question, Kareem. And this kind of comes back to another one of when you're using something that Terraform relies on to run, you're kind of in the question of how do you solve the chicken and egg thing? To provision OIDC trust policies, you need something to orchestrate it. And usually we use Terraform to do it for us. So in our case, we have a couple different approaches. Different teams prefer different approaches. What we tend to do is have a very simple, very basic little CLI script that's being saved to a GitHub action, and we get to manually trigger it with an input. So all we do is, hey, for this particular AWS account, create an OIDC role for me with this level of permissions. And within seconds, we have it spit out a Amazon resource name we can start using immediately. If you are doing this at scale with multiple teams and projects and having a security team manage it for you, I would recommend almost certainly having a separate CloudFormation or Terraform/Tofu project purely for managing the provisioning of OIDC trust policies across your org. Thanks, Kareem.
Yes, thank you, Kareem. And Jason, you mentioned the chicken egg problem. If you want to touch on it here, Jason had put this into the Q&A, and I had a couple of upvotes. How do you solve that Terraform backend chicken and egg scenario?
Absolutely. I've gone ahead and posted yet another link, sorry for spamming the chat. And this one's a great one because this isn't a project I'm associated with, but I highly recommend by Cloud Posse. And this project, they try and target this very question. How do you solve this Terraform backend chicken and egg? And I love the simplicity of their approach. Hey, if you can't use Terraform because you don't have the backend for it yet, just use your cloud provider's native functionality to do it for you. In this particular case, I use the example of AWS since that's the most prevalent, but they've got this little script that's organized, managed, and it makes it ideal to run it, have your backend provisioned out automatically and ready to go, and it's covered by CloudFormation. So if in the ever you do want to go back or change it or amend it, you still have that possibility. Thank you, Jason.
Yes, very good. All right, a question here from, we've got 9 minutes, so we've got some time to get through some questions. Neville asks, after the supply chain compromises earlier in the year, how paranoid should we be around third-party GitHub Actions, especially ones that vend tokens that can access our cloud environments?
Love the questions, and to be blunt about it, I would say very paranoid. This is something I do take fairly seriously, given that for the bulk of this presentation, I've talked about a random open source GitHub action. Sure, the easy answer is, well, you can look at the code if you're worried about it, and that should be fine. But I think we're all too aware malicious actors can and do cause upstream chain attacks through your dependencies. So I would say, for starters, you should be worried and concerned. And for a second thing, if you do happen to be looking into the security aspects of this particular GitHub action, I'll pop another link in the chat again. I'm very surprised, pleasantly surprised I managed to have this organized. But for the security aspects of this particular GitHub action project, there is 0 dependencies. So there is no other dependencies that this relies on. Every single Terraform command, automation, PR creation, it isn't relying on some other third party. It's just writing out the scripts by hand. So all you're relying on is GitHub. That's the starter. For the second bit of it, and this goes for any GitHub action, I would always recommend pinning to commit SHAs. Never just blindly rely on pin to version 5 and you're good to go, because that's the easiest way for someone to sneak something malicious into a version and suddenly you have downloaded that into your CI pipeline automatically. But if you use commit SHAs instead, not only are you very specific about which version you're using, but you're also making sure there is no scope for third-party upstream attacks to sneak in, at least through that vector. Thank you.
Yeah, it's a great question. Great question. All right, one last here. What kind of IAM role permissions do you have for the OIDC assumed role? Is it wildcarded?
Not quite, Dhruv, but that's a great question. I might ask for a little bit of a follow-up on that, because when you mention wildcarded, is that in reference to the role permissions or who can assume the role? If it is for the role permissions, I would say it's not wildcarded, but we tend to delineate between 2 different ones. When you're running apply, we pretty much give it permission to anything and everything, aside from the usual basics like, hey, don't delete yourself. That's always helpful to have. But when it comes to planning, we realize there isn't really anything Terraform or Tofu is doing in the plan stage. So it doesn't need write permissions. So it tends to have read-only access permissions by default. And that's the way we've tried to delineate our permissions boundary between the two. Thank you, Dhruv.
Yes, and he confirmed role permissions. Yep.
Oh, perfect.
Yep. All right, great. Someone did sneak in another question. Let's see here about Azure pipelines. I'm using Azure pipelines with Terraform. How to avoid confusion? IaC for multiple users, considering Terraform state files should be maintained properly.
I've been reading this, and I've got to admit, I'm not entirely certain what's been meant. If I take a guess of, given that it mentions the TF state file specifically, maybe it's a question about state locking. So if multiple users are running plan or apply at the same time, how do you avoid the confusion of making sure only certain users have access to the state file and it's not being overwritten by someone else at the same time in the background? And if that's the case, that's a super valid question, and I'm happy to report that's something that's built into both Terraform and Tofu for a long time. So I've just posted another link. It's referencing to a documentation page in OpenTofu. The exact same equivalent exists in Terraform. But all that does is that whenever you're using any modern cloud platform where you're storing your state file, be that a GCP bucket or an AWS S3 bucket, they almost always tend to have some sort of state locking mechanism built in. I mean, most recently, Terraform and Tofu in their, I think, V11 and V10 releases, respectively, created support for non-DynamoDB buckets. So anytime you want to touch an S3 bucket, it almost certainly is being locked and preventing anyone else from modifying it at the same time.
Fantastic. All right. Well, that's all the questions that we had in the queue. Thank you very much, Rishav. I think there were several comments in one of the questions around amazing presentation voice, nice, calm, and collected. I think someone asked if you have a recommended dictation course, so I'll let them follow up with you on LinkedIn. But yeah, overall, fantastic presentation. Thanks, Rishav.
Huge thank you for everyone for joining me at this IaCConf spotlight today and taking a security-minded approach to implementing IaC. Over to you, Gareth.
Thanks. So that concludes our first IaCConf spotlight. We do have a survey, which I will drop in now. You should see a link come up. The reason that we were able to host this spotlight on security is because we got 270 odd responses when we did the event back in May, and we asked what type of content do you want to hear, and that's how we were able to pull together this great content across these 3 sessions, because we were listening to you all in the audience. So let us know what you want to hear about next. We've got some good data from the event in May. Any feedback helps us make these better. We'll send up follow-up emails that'll have the recordings. You'll get some more emails with links to the IaCConf Connect event that we're doing at KubeCon, as well as some other content that we can share. PDFs of the presentations, once we can confirm with all the speakers that they're okay to share those, we can package those up and send those in some emails as well. And one note on the survey link, that is a way to get some IaCConf swag. Right now, we can only send within the US. But again, we're doing IaCConf Connect for KubeCon North America this year. I'd like to think we're going to do it in KubeCon Europe next year. So if you're in Europe, that would be a chance to get your hands on some IaCConf swag. But whether they're in the US or not, giving us this feedback is super helpful. So thank you very much to everyone for joining. Thank you to the speakers, and we'll see you at the next IaCConf event.